All right, so let's try an example of this unit normal, principal unit normal vector. So we have this helix, so we're going to need to find each part. I'm going to change colors. I don't love writing in black. So r prime of t is, okay, that's going to be negative 3 sine t. Derivative of 3 sine t is 3 cosine t. And then derivative of pi t is pi. All right, so we have r prime. Let's go ahead and find its magnitude. These can get pretty gross in the homework, just a heads up. So we got 9 sine squared t plus 9 cosine squared t plus pi squared. All right, so this magnitude is going to be equal to 9 plus pi squared. Right, I can factor out the 9 of that thing and grab that. Okay, so it's nice, pretty. It's not even variable, meaning it doesn't change. So let's find r double prime of t, that vector. So we got negative 3 cosine t. Derivative of 3 cosine t is negative 3 sine t. And then the derivative of pi is 0. This magnitude oh, actually, I don't think we needed r double prime. Yeah, not yet. Okay, so go ahead. We may need that. If you want to keep it, I'm going to erase it. I don't think we need it really. I think we're going to have to do something else instead. So my tangent vector, by definition, remember, is r prime of t over the magnitude, making it a unit vector. So we have 1 over the square root of 9 plus pi squared times that vector. I'm just going to duplicate this vector. Go. Oops. Let's see if I can grab it without grabbing something else. There we go. Forgive me. I am struggling with tech. Okay. So I'm going to duplicate that. There we go. And I'm going to shrink it so it'll fit. Goes right here. Close off that pi. All right, there we go. So there's my tangent vector. No prime here, just tangent. All right, that is definition of that. Sorry for that if I led you astray there. And some of you guys are probably dying the last minute trying to fix that out loud, screaming at me. Okay, so I want to find the normal vector. Okay, the normal vector is t prime of t over its magnitude. All right, so I got to find the derivative of what's there. To take this derivative, that thing out front, this thing is just a constant, so I'm just going to leave it there. Right, times, okay, I take my derivatives now of the inside. Derivative of negative 3 sine t is negative 3 cosine t. Derivative of 3 cosine t is negative 3 sine t. And then the derivative of pi is 0. All right, so earlier we did r prime, but it wouldn't have been a unit vector. Okay, and then we got to put the magnitude of that thing over it. So it's going to be 1 over the square root of 9 plus pi squared. And then it's times the square root of 9 cosine squared t plus sine squared t. Right, so t prime, that was just t prime actually. Oof, I'm sorry you guys, I'm kind of all over the place in this one. This, what we just found here, is its magnitude. All right, we're about to put it all together. I'm sorry guys for the few mistakes there. I think that's it. We're missing a 9 there. All right, so that's the magnitude. We don't have to do the constant because the constant can come straight out as long as it's positive. So that's why that's there. And then I took the square of both and took the square root. This is going to end up being 9 over 9, the square root of 9 plus pi squared. Not pretty. So the normal unit vector is going to be, and things are going to cancel out nice and pretty for us. If you imagine putting this on top and that on bottom, right? We'll write this definition here, t prime of t over its magnitude. Things are going to cancel out. I'm going to get 1/9, 3 cosine, negative 3 cosine t, negative 3 sine t, 0. So that is my normal vector at that point, given that my function is what they gave me up there at the top, the helix. This is the normal vector, so this would be pointing, any t I plug in and I get that vector, it's going to be pointing in the direction that it is turning, which if this is a true helix, you know, it's spinning around the, this one is spinning around the circle around the origin, and this would be pointing towards the inside of the circle the whole time.